You guys how to turn this into the quadratic formula. I only have like 2 minutes to explain it, so let's go by completing the square. Okay, first, you're going to isolate these. X squared plus b x. We're going to isolate them from c, 0. Now, you're going to factor out a. Why not factor out x? Explain it to you later. So, ax squared plus b over ax, because these will simplify to bx plus c over 0. Next, you're going to complete the square of this, which exactly means that you're going to divide it by 2 or times it by 1/2, and you're going to square it. This is going to be used for simplifying later. So, what does this get us? Well, b over 2a squared, b squared over 4a squared. Okay, add up to here. So, ax squared plus b over ax plus b squared over 4a squared plus c equals, do we add 0? No, because we added something, we have to balance it out. What exactly are we adding? Well, we can't just do this on itself because it's attached to the a. So we're going to multiply the a to here, bx over 4a, because this a cancels out with this a. This is what we add over here. Okay, so, drawing the whole thing out again. B over a squared plus plus c equals b squared over 4a. This is where the completing square comes in, because this is going to allow us to simplify this further. Now, as the home sheets we had before, the homework, it showed us to take the middle term, divide it by 2, square it, and it gives us the last term. We're taking that same principle. So because of this, we can now simplify it to a over x plus b over 2a squared plus c over b squared over 4a. Okay? A, x. No squared. Why was I doing that? Okay. Plus b over 2a entirely squared plus c over b squared over 4a. Erase all this. Minus the c. X plus b over 2a squared equals b squared minus 4a. See, we're trying to get the a. We're trying to get everything over here, so we're going to divide the a. Divide the a. This will get us x plus b over 2a squared equals, this will be times this, so b over 4a squared. And remember, we're just dividing that out, so it'll be c over a. Now, we need to subtract this further. Problem is we don't have a least common denominator. How we do that? We divide this by this, get 4a. So, 4a, 4a. Okay? X plus b over 2a squared equals b squared over, times this out, 4ac over 4a squared. This should look familiar, means we're close. So, next, square root it. Okay, x plus b over 2a square root it means plus or minus, because you're going to be either one of them. So, plus minus square root of b squared minus 4ac. We can square this out, gets the perfect square, to 2a. Okay, next, we have plus b over 2a equals plus or minus square root b squared minus 4ac all over 2a. Multiply the entire thing by 2a. Means we'll mark that out, mark that out, mark that out. But this is here too. We divide that by 2a. Means we're left with 2 over x over 2a plus b equals plus or minus square root of b squared minus 4ac over 2a. Subtract the b. Subtract the b. X, oh, this is not here anymore. I don't know why I put that there. Okay. X equals negative b plus minus square root of b squared minus 4ac. Remember, we had the 2a over here. Multiply 2. Just messed something up. We're going to rewind this a bit. Okay. I don't know why I did this. So this is actually 2ax. Okay. Okay, got a little bit carried away there. 2ax. Therefore, we're going to divide 2a. There we go. Divide 2a. Therefore, x equals negative b plus or minus square root b squared minus 4ac over 2a. We got our answer. This is the 5th take I've done this. I am tired. This is exhausting. I think we're good. Have we recorded? Okay. Jeez. The quadratic formula. Let me take you back to a time where the Babylonians took the mathematical tie. With square roots and circles, they had it all, well, all before their great fall. Now speed up 30 years or so to a Greek named Pythagoras the Samus. He took the throne. He and Euclid, though miles apart, had solutions to the equations with the geometric heart. 2 decades further, we meet a mathematician by the name of Brahmagupta, an Indian man. He was different from the rest, crazy in the mind, using irrational numbers. What a pleasant surprise. So now we have an equation that we can all use. So what's the purpose in our future times, when calculators lie the pockets of humanity worldwide? Ever thought of rockets to pursue to space? So though the quadratic can't solve taxes, it has its place.